Hello guys, welcome back to another video where we are exploring the Raspberry Pi and its operating system. I have done some things in the background from this video and the previous one. First of all, I have installed something called DNS utils. Now, if you're having issue installing something, remember to always do an update first before installing. Can't seem to type. If you put this entire command in, you should be able to install it. Now, if you have been looking around onto the internet while you have been watching my videos, and you're looking at a lot of stuff on how things work, and you need to put in a lot of different names and stuff, what you need to do is check first of all what sort of OS you are running. It's as simple as cat etc OS release, and you will get the information. This Raspberry Pi is running a Debian 12, codename Bookworm. So that's very important information when we're looking at, for example, sources. Let's clear this. For example, sources list. If someone were to tell me that I needed to put in another source, I would need to update this one to my correct code name. So, for example, if you are watching this and it doesn't say Bookworm here, you need to put in whatever is the version code name here. Now, this is obviously correct since it's a fresh installation, but let's say that somebody were telling you to update this. See, and it said you are pasting this into here, and suddenly it says Trixie there. Trixie updates instead of Bookworm. What you would need to do is update this to Bookworm before you're able to save, because otherwise you would get updates for a different version. This is like me telling you to, if we were running Windows 7 instead of Windows 10, for example. It might work, it might be some issues. So try to stick to the correct version. There we go. Now you might be wondering, what sort of thing were you doing there, where you are listing the sources? What is that? So when you are running this command, the sudo apt update. What we're essentially doing is you are going to this address. You can even click on this address and you see, you can go here and you can look at what this is. From what you can see, it's a load of, basically it's I don't even know what it's called. It's an archive. Yeah, it's just here, right here, of all the stuff. So we can even follow this along. See here. It tells me I want to go to Bookworm. I want to go to main, and these are all the sort of stuff here. See, and since we are running the ARM64, this is the one. Let's see if I can look at the packages. If I press here, maybe I will download it. It seems like that. Oh well, what normally happens when you press update is it checks the checksum of the files, and if there's a difference, it controls what sort of packages has been updated. So here we go. Let's go up again. You can see a lot of stuff here. Bookworm, bookworm updates, proposed updates, backports, sloppy, bullseye, all this sort of stuff, really. Now the latest version from Debian is called Trixie, so that's 13, and bullseye is the, if I remember correctly, 10 or 11. I believe it's 11. So bullseye is all the stuff here. So that's essentially what you're doing when you're typing in sudo apt update. The Raspberry Pi goes into this this URL, this web page essentially, and just looks for the bookworm and then the main and everything, and pulls all the information down and sorts it. So when we're doing that, it hits both all of these sites and downloads the package list. So yeah, very good. We learned that. Now let's say that I wanted to see, all right, when I am hitting up the deb.debian.org, what really happens? What am I doing? So when I, for example, want to go through deb.debian.org, when I want to ping it, what my computer is doing, or the Raspberry Pi in this case, it's first of all checking, all right, what even is deb.debian.org? That is contacting the DNS server, and the DNS server, we can use a command called dig. Now I installed DNS utils in the beginning of the video. If you remember, if you haven't done that, you need to do it. And if you type in dig deb.debian.org, we will get some information. So my computer, or the Raspberry Pi here, when we asked for deb.debian, we asked a server here. In this case, it's 10.0.77.232. It's on my local network. And the answer is this. So this is the answer. 199, etc., etc., which is very interesting. And we saw that information over here as well. We are pinging this. And what a ping essentially means is it is just sending a small package that it wants to return to the Debian server. And that took 5.70 milliseconds approximately. Yeah, the average 5.7 milliseconds. So this is all very interesting information. We can see how long it took for the query. Since I have it locally, it took 0 milliseconds. Very interesting. But that just means that it's fast. Let's say that I would like to do something like verify.com. I wanted to see what that means because we haven't checked that before. So when I did that, I asked for raspberrypi.com. I got 2 answers here. And that took a lot longer, 147 milliseconds. Now that isn't a very fast DNS server, but we will talk about that later. So let's see if I do that again, it should be 0. Yeah, as you can see. Now what this means is how long left until an update will be requested on the DNS server. So yeah, we can see a lot of information in the flags and all this sort of stuff. We got 2 answers. Now if I ping raspberrypi.com, we will get either one, as you can see. So we got 104 on the first ping and 172 on the second. So when we get 2 answers, it's just the one that answers first sort of situation. It isn't really that special. You could pick either one of these and still reach the same server. Now, what even is an IP address? So what we're going to do now is we're going to use something called a traceroute. Now, some information might not be seen here, and some information might be seen. It isn't really that special. What we're going to do now is we're going to take the 104 IP address of the raspberrypi.com. We're going to put in traceroute and we're going to see what happens. I don't have traceroute installed. Give me a second. Let's see here. Will that work? I am unsure. Seems like it has been found at least. And let's try that again. Now, this isn't completely true because what we're essentially doing is we're asking for every sort of hop between the working 001 to the raspberrypi.com site. Now, how did that work? So the first hop was to the 10.77.1. That is my local router. There's nothing special about that. And then there is my ISP. So that's likely the closest router that my ISP have. It is likely some sort of bigger switch or something close to me. And then it travels inside the network of my ISP into what might be a gate, or how I should say, a gate might be the wrong word, but let's call it that. It's a jump from my ISP to another ISP. In this case, it's Telenor, it looks like. Depending on what sort of stuff you have, you might not be able to see much. As you can see, I have the ISP called Ownit. They are, I believe they are owned by another ISP called Telenor. So it jumped from Ownit to Telenor, from Telenor to Telenor, what seems to be some sort of likely inter ISP connection to Telenor.se to Telenor.net, and then it traveled from Telenor.net, probably some sort of European server or router or something, to where the raspberrypi.com servers are, which are likely here, then their data center likely, and then the final destination. So from my working 001, it took 9 routers in total to get to the destination, or 8 maybe. So 8 hops for me to get my my information across to them, which is very interesting. And these numbers that you're seeing here, they aren't really that good of an indicator of how long things take, because these big routers that we have here, their main purpose isn't to answer to what is essentially a ping message. So my Raspberry Pi, when I'm doing the trace route, it is essentially looking up all of these hops, and then it's sending out a ping. So it's sending out a ping to this one, sending out a ping to this one, and this one, and this one. So we can get all this sort of information. But these big servers that we're seeing here, or routers I should say, their main purpose isn't to respond to this this sort of ping message. Their main purpose is to route data as fast as possible. So as you can see, it's even longer response time here than it is for the server here. So don't take these sort of numbers as any sort of indication that something is slow or anything like that. Just keep that in mind. So this is how a simple ping, DNS, and traceroute works, how the network works. You can try this on any sort of stuff, really. You can even type in google.se and we can get a lot of stuff. Here we go. From what we can see here, we are essentially doing a lot of the same stuff as before, and we are jumping off on a different location this time. Probably one sort of big interconnect that happens here and here. So the 6 and 7 hops from my ISP are essentially the same, and you will likely see that as well. So that's how you can check out some interesting DNS and networking quirks. Have a great day.